to you about wetlands. I happen to have been dealing with wetlands a little while here since I'm in Brownville, and before that, when I was in Tamaulipas, I was also implicated in several projects related to wetlands, freshwater wetlands, also estuaries with mangroves, which are another type of wetlands. And many things involved with that, even with crocodiles. We did a study with crocodiles in a couple of lagoons near Tampico, with neotropical otter, which is also is an umbrella and also a flagship species in wetlands in southern Tamaulipas, etc. Do you think we can? Yeah. Okay. So today I'll be talking about three. I don't know if we'll have the time to get to the last one, but in theory, three case studies that relate to wetlands in aspects that, in the background, have to do with the restoration, the recovery of degraded wetlands, and the follow-up of that recovery after the restoration effort was applied, right? And before that, just to set the stage and to put us on the same page, the definition, one definition, just a reminder of the ecosystem, some of the ecosystem services that wetlands provide, and some words about degradation, restoration, and monitoring of wetlands. Okay. So this is the definition by the International Convention of Wetlands. You may have heard of this word. Ramsar is the reference for that convention because it happened in an Iranian city called Ramsar. So it's now stick the name, the short for the convention, and please take a few seconds to read this. So you may have noticed, and I underline this word here, water is not necessarily explicit nor implicit in the definition of wetlands in your book. I look at that page in that chapter of your book. So wetlands, there can be several definitions. This is one definition that is widespread because it's from the International Convention and includes the water. So wetland is not just waterlogged soil, right? It's also bodies of water that are shallow. In that definition. So that's the definition I use, but again, it's not the only one. Like in your book, this part water may not be that explicit and still valid. Yeah, there are wetlands that are called like that and do not have freestanding water on the surface. Okay, so includes natural and artificial. I will. One study case is about artificial wetlands, permanent or temporary, etc. Even the coastal waters, as long as it's not too deep, right? So, with that in mind, just a reminder of ecosystem services. You know, there are, in general, talking in general, ecosystem services can be of one of four categories: provisioning, supporting, regulating, cultural. In the case of wetlands, if we want to talk about some examples, or an example of supporting services is nutrient cycling, for example, formation of soil, or those services that support the other services or that are necessary for the other services. So that's why they are called supporting, because they support the rest of the services. Provisioning services of wetlands, fish. Wood, if we're talking about a wetland that has mangroves in tropics, so wood is used for is something. Fresh water, if we're talking about freshwater wetlands, clean water. So we take wetlands can provide fresh water. These kind of things. Regulating is buffering storms or mitigating flood, right? Sequestering carbon, therefore regulating climate, sequestering nutrients, therefore regulating or filtering water, these kind of things. And cultural services, recreation, including fish, landscape, sightseeing, these kind of things, okay? So, important type of biome, important type of habitat, very important in fact. Okay, so few words about very common threats of wetlands, or threats that tend to degrade wetlands. Well, that's a very common one, the disturbance of the hydrology of that wetland. Okay? When there is damming, when there is filling, when there is obstruction of tidal flows, these kind of things, that disturbs or disrupts the hydrology of that wetland, and that's a big issue because many things are connected to that. Just think on the tidal flows on an estuary, which is one type of wetland. If tidal flow is disrupted, the estuary condition of that wetland is no longer, right? Disturbance of salinity regime, that applies, of course, mostly for estuarine wetlands. And in front of each of these, I put approaches, general restoration approaches for these common threats. For example, for the disturbance of hydrology and the disturbance of the salinity regime, restoration approaches deal with the restoring of ecological flows. What does that mean? Ecological flows means the flows of water, can be fresh water. We were talking about a freshwater wetland, and also we are talking about an estuary. Freshwater flows and minimal freshwater flows are necessary for maintaining estuary conditions. In a positive estuary, it's not true in a negative estuary. Positive estuary is estuaries that have this mix of fresh and seawater. If there is not enough fresh water, that estuarine condition is no longer. All right. So ecological flows means minimal flows for ecosystem processes to be maintained, and these flows can be of fresh water and also, in some cases, tidal flows. The third case study that I may have the time to show you has to do with that, and also the second. The last two studies have to do with the restoration of tidal flow as the first effort in the restoration of that. Many things follow, but that's the first step. And can be then passive restoration after the first effort is established. Another common threat is pollution with nutrients, right? Organic loads, nutrient loads, estuaries, wetlands in general are at the lowest part of the landscape, therefore are at the lowest part of a watershed, can be big, can be small, so everything tends to drain in. So they are relatively, they do collect runoff water one way or another that may be loaded with organics, with nutrients, and with also other toxic pollutants that may not be nutrients, something else. But a common pollution is an enrichment with nutrients. We are talking about nitrogen, we are talking about phosphorus, these two main nutrients, which are not toxic, right? Those are essential nutrients for plants and everything that is alive. They are not toxic, but when there is an excess of those nutrients, changes happen, the systems degrade. One consequence of that degradation is a state that is called eutrophic. Eutrophication is the process which is a consequence of nutrient enrichment in bodies of water, wetlands, including wetlands. Okay, have you heard about eutrophication?
No.
No? So eutrophication means, again, an imbalance in the aquatic community. For example, think of a lake or a little pond that has plenty, has fishes, has phytoplankton, microalgae, and microbial, small organisms, microinvertebrates and invertebrates and these kind of things. When there is nutrients arriving in runoff water, good nutrients that can come from a nearby field that has been fertilized, or can come from a nearby wastewater treatment plant effluent. That water has been treated, but not all nutrients are removed. It's seldom the case. or can come from a septic tank of a cabin that is built next to the little lake or little pond. This kind of thing, there's always leaks. So those nutrients end up in the water, and there is a differential response of the microalgae. You know, the little algae, the phytoplankton, little algae that is suspended in the water that gives the brown or green coloration to some waters when there is plenty. Well, there is a community, there are plenty species there in the phytoplankton community. There are plenty species. Some species will respond to the nutrients differently than others. Some species will start growing like hell, reproducing and having a population explosion, dominating the other species and overtaking the whole body of water, and then the water looks like a spinach soup at some point, in extreme case. So this is an imbalance. Why? Because, well, other species of phytoplankton have been displaced, and this excessive amount of biomass, I mean, is green, right? When there is light, it's producing a lot of, I mean, it's photosynthesizing, therefore it's producing also a lot of oxygen. Therefore, during the day, plenty of oxygen, no problem. But the problem is at night. At the end of the night, after several hours of darkness, there is no photosynthesis during night, just respiration. So the dissolved oxygen, the oxygen that is dissolved in the water that fish need, right, and everything that lives in the water need, will be depleted towards the end of the night. And then you have a fish, a mass fish kill. At the end of the night, the beginning of the day, you will see plenty of fish, this kind of thing. So that affects obviously the diversity of the water body. So how this is approached? Well, of course, reducing nutrient loads. And it may restore after that, it may recover on its own. Sometimes it's not the case, and then a second step is needed, which is called biomanipulation. That means manipulating the fish community in order to have less planktonic fish, or fish that eat the zooplankton that eats the little algae. Zooplankton eats phytoplankton. When there is too much planktonic fish, they are consuming the zooplankton, therefore nobody consumes the phytoplankton, and the condition of eutrophication condition, green soup, remains. So that can be needed, and biomanipulation implies introducing or enhancing the population of piscivorous fish, predatory fish that will consume the planktivorous fish and lower the pressure on the zooplankton, and therefore the phytoplankton will be consumed, water will become clear again. Even if there are no nutrients, that may remain for years. And then, if there is no phytoplankton using the nutrients in the water, macrophytes will use them. Macrophytes are plants and algae that are not microscopic, right? That are attached to the bottom or floating. So they will be using and growing faster, but the water will remain clear. Okay. Another common threat is the degradation of the riparian zone. Riparian means the shores, yeah, from the water, few meters in. So this is the riparian zone of the interface between water and the terrestrial system. This is due to many things: construction, feeding, you name it. No? So the approach is obviously rehabilitating that area. Many times is regrading vegetation. Riparian degradation is channelizing a river or something. It's also, yeah, or Resaca's here with the, you know, with the, what do you say in English, the walls, the
bulkheads.
Yeah, something like that. You know what I'm talking about? There are houses in front of Resaca and they have a wood wall.
Oh, retaining wall. Retaining wall.
So this is obviously degradation of the riparian zone. So how this is rehabilitated? Well, this is removed. The slopes are naturalized. Sometimes the vegetation, etc. So this is just very general. Most common threats, most common approaches to those to address those threats. Now, to talk about monitoring, to talk about before that, to talk about degradation and then recovery, this is a very nice figure that it was published in the 80s by Tony Bradshaw, one of the the fathers of restoration ecology. This is a relatively new discipline. You may have seen it. If you have not, you will understand many things about how ecosystems degrade and recover. So you can think first of ecosystems having two dimensions, right? Structure represented with the horizontal axis here, and function represented by the vertical axis. So what is structure? Who's there, who's not there, in what proportions, how complex is the food chain, etc. So we are talking about the biotic communities. We are talking, what are biotic communities? Can be the community of birds in a rainforest, can be the community of macrobenthos in a pond, the community of fish in a pond as well, can be the community of plants, etc. So there is always a way to measure how many species are there, in what proportions. So that is one indication of structure. And what is ecosystem function? Is the metabolism, is the processes, right? Photosynthesis, plant growth, primary productivity, parasitism, herbivory, all these are processes. If you want an analogy with the human body, structure is, your limbs. If you have a problem in structure, maybe because you are limping, you have an injury in your leg, this kind of thing, that's a structural problem. Or you don't have a leg, that's a heavy structural problem, right? So who's there, who's not there, in what shape, what proportions, right? And what's the function and the analogy? Well, if you are diabetic, you have a functional problem, a metabolic problem, this kind of things, okay? Once this is clear, then you can say, okay, an ecosystem that is not damaged, an ecosystem that is in good shape, will have a well-developed structure and is functioning in high rates. So you have something located here. When there is a degradation, there is a reduction in both structure and function, and the degraded system will be closer to this corner here. Okay. So now, when there is an attempt to recover, an attempt to go back to the original state before degradation, then there are options. There is primary succession or ecological succession. This is the natural option. It takes a long time, sometimes never finished. And there is these options that are options in restoration, that means that mediated by the intervention of humans. So it can be the full restoration all the way. This is the only thing that is really called restoration in a proper way, when you have the recovery of the full structure and the full function. This is almost utopic. Once a system is degraded, it's very rare that it's fully recovered. There will be, function is more easily recovered. You can help, nutrient cycling, decomposition, primary productivity in the original rates, but some species will never come back. So structure is almost impossible to completely recover. But an intermediate position is rehabilitation in the direction of restoration, but not fully. So that's more likely what we are talking about when we talk about restoration, right? And a different way is called reclamation or replacement. It's better replacement, the term. So you may recover the function, but you don't recover all the structure, but the ecosystem is functioning. It's a different ecosystem, but it's functioning. Okay? You don't have the same species there, but it's capturing carbon, it's cycling nutrients, it's decomposing turnover, organic matter turnover, etc. So when we talk about degradation or recovery, we are talking about this, so think about this. When we are talking about monitoring the recovery or monitoring the success of any restoration efforts, we are talking about indicators of structure, something that measures somehow the structure of one community or two communities, and indicators of function, something that measures a rate of a process. I like to use the composition. The composition rate is my favorite functional indicator of function. Okay? Any questions? Okay, so now I will go through the case studies. I will go fast over some slides, right? But please just raise your hand or ask me if there is something that you want me to detail a little bit more. I'll be using this, perhaps, for example, in the methods. I will stop in just so you understand why we measure this, or what is measured in is commonly measured in a wetland. What kind of metrics, what kind of measurements, right? So this is one project. It's about resacas, right? You're familiar with that term. So resacas is it's not just oxbow lakes. It tends to be, people tend to say, okay, it's the same thing as oxbow lakes. Yes, but not completely. Oxbow lake is one type of resaca, but it's not the only one. So if you want to be more correct and more generic, and say the right definition, resacas are all these tributaries of the Rio Grande. Okay, so the Rio Grande may have passed one way or another, may have made an oxbow lake, or no oxbow lake just passing through, and now it's passing to another. So there is a bed, an old river bed that remains, and that when it's filled full with water is called resaca locally. Okay, so all these tributaries of the Rio Grande, this is a resaca. Oxbow lakes and more. Okay, so this was an experiment, a study. This is one of my graduate students. Well, she finished in 2014, so this was done, finished at that time, and we had the opportunity to. So remnants of at that time, she put that. So this is not just that, as I just said, right? So in the Brownsville area and the region around, which is agricultural, the landscape is agriculture, irrigation, agriculture, resacas are maintained, are managed. So the riverbed, the old riverbed, is filled with water from the river now, and they are maintained. So in the city, the resacas are maintained visually, to have a visually appealing landscape, and also they are used by QB as water reservoirs, and also to control flooding when there is rain, a lot of rain. And in the countryside, they are really used as reservoirs for irrigation water. So they are maintained filled with water. So those are artificial wetlands now. Those are novel ecosystems. The resacas do not used to work like that, to function like that. They used to be ephemeral wetlands. So when the river flooded, they fill with water, and then they end up drying a few months later, and things like that. And so resacas are really novel ecosystems when they are managed, because they are permanently flooded. That was not the natural state of resacas. But we have to admit that resacas today are very critical freshwater wetlands, almost the only kind of freshwater wetlands in the Rio Grande Delta. Another thing that can help define or add to the definition of resacas is resacas are deltaic freshwater wetlands. So in other words, wetlands that are in the delta of the Rio Grande. Okay? So they are deltaic wetlands, and they are very unique, as you know, and there are not much more than that in terms of fresh water in this area. So they are critical for wildlife, for example.
Sorry, the battery went low.
No problem.
Get it.
So this first study, so it's about resacas, and we had the opportunity, and it was a really opportunity. That's why we decided to do it. That when Leah was arriving here as a graduate student, there was one resaca at Ceibal Palm Sanctuary that was being reflooded for the first time after many years. I know you have visited recently Ceibal Palm Sanctuary. They used to have a resaca still there, but upriver or upwater of that resaca, there is another one that was flooded at that time. It was flooded in 2013, if I recall well. So we had the opportunity to be there at day one of the reflooding. And then we have the other resaca that is there, you know, the one with the blind birds. So that has been there for 4 years at the time of this study. Now it's more. And then many other resacas nearby that we could pick one as an old resaca. So we had 3 resacas. Thank you. So we had 3 resacas to test, one new and the other 4 years old, and the other, well, at the beginning was 2 years old, at the end of the study was 4 years old, and an old resaca. And then we compared the microbenthic community, one community that lives in the water, which are invertebrates. They are called macro because we can see them with the naked eye, but we are talking about things like this, or not more than this, right? So still small invertebrates, but you don't need a microscope to see them. So that's why they are called microinvertebrates. So we decided to look at that community because it's been used in many places for indicator and assessment purposes. So it's a standard methodology to look at those, and it's been successful in other wetlands. So we decided to use them and look what happened after 1 year. I mean, from day 0 to 1 year later after reflooding, and see what happened with the community, how the community developed from day 0. So that was a unique opportunity to have that. So we jumped on that, and Leah did a great job completing the thesis. We have already published one paper about that. So macroinvertebrates have many advantages. So these little things, including, as you can see, for example, including insect larvae, right? And those are fully aquatic organisms. So some are fully aquatic, some are temporarily aquatic, what they are larvae. But all this is the microinvertebrate community altogether. Okay, so they are being used for that many times. They are interesting because they do not move too much, so they are there. So you know that whatever is happening to them is the reflection of what happens in that particular pond, or resaca pond. It's not like a fish that may be moving, or maybe not. But the fishes are also useful to have this difference there. Well, they are sensitive, so some species will not prosper under certain environmental stress. Some species will dominate under certain environmental stress. So you just have to read, looking at the community, who's there, who's not there, in what proportions, is there any exotic species or invasive species, this kind of thing. So you just read all this information, and then you can tell what's going on with the pond. So we are talking about day 0. So we are talking about measuring, assessing, and narrowing down indicators of development, or restoring an aquatic system that was not there anymore. So, and we are looking at this. Over time, at the beginning, pioneer species arrive, right? And after a while, we have a higher diversity because pioneer species, early succession, and secondary succession or late succession species start arriving. So you have a mix of the 2 groups of species, so you have high diversity. But as time goes on, the pioneer species will be completely replaced by late successional species, so diversity will go down because you don't have the 2 groups. So that was the assumption. It's something that we could confirm at some point. So we look at, that was our hypothesis in some part of our hypothesis at some point. So of course the colonization, we're talking about a new resaca, therefore we're talking about colonization, will depend on how close are other resacas, and if those resacas are flowing water into this one, so water can be a vector for some organisms. Other invertebrates can disperse, for example, the insects that have an aquatic stage and then they become adults and they can fly, or they can attach to animals, so they can disperse much more. So this is called active dispersal, and there is passive dispersal in the case of animals or invertebrates, have to disperse with the water, with the flow. So at the beginning, we were expecting fast colonization rate, and the first species to arrive because of this active dispersal would be insects. Okay? And late colonizers would be passive dispersers, like for example, little snails, aquatic snails, gastropods. And, so we'll see what happened. So again, we were talking about indicators. Remember what I told you? So structural indicators, functional indicators. In this particular study, we were focusing more on structure, the macroinvertebrate community. Who's there, who's not there, in what proportions, exotics, not invasive, yes, not these kind of things. We were not looking at this in this particular study. In the other studies, yes, we did look at this. However, there are some compromises that you can do with the structural determinations, which is called functional groups or functional feeding groups. The word function is already there. I will explain that later. So it gives you an idea of the functioning, but it's not a direct functional indicator. So we are looking at the structure in personalized with the macrovented community. But again, there may be some insights into the functioning as well. I'll show you that in a moment. So, and it has to do with this, okay, functional feeding groups. So you can say, okay, I have just scrapers, or I have just filter feeders, or I have this proportion and another proportion. So in that sense, you are looking at the groups that function in the trophic, in the food chain of the invertebrate community. Okay, so it gives an indication. So one Resaca monitored from day 0, and the purpose was to monitor and the development of the community, or the colonization, if you want, comparing with other Resacas, and also trying to narrow down potential indicators of recovery in the case of restoring from 0 a Resaca. So you may recognize this. This is Sable Palm Sanctuary. This is almost preserved. So the 2 Resacas within the sanctuary are here. The new one here, the intermediate, the one that was 2 years old when we started. And this is an old Resaca in an near an agriculture operation that was used for storing, and that's been flooded for many years for storing water. So the level was up and down, but never dry. Okay, because they were using water and pumping water back with the irrigation district. So that's how they look. So this is the new Resaca before flooding, right, at Sable Palm, right after flooding. And have this section here is the view that was flooded. It's an old Resaca bed that has been dry for many years. Intermediate Resaca is the one. This picture is from the blind, right? You know that the blind is right here. And this is the old Resaca, more than 10 years flooded. This is how it looks. So it has a good riparian community, even with some sable palms, which are part of the riparian community in this area. But the rest of the landscape is a little bit farther is orchards, citrus orchards. Okay, so this is just to show you the ways that we use and many people use to sample this kind of community, this kind of animals, right? So there are animals, invertebrates that are suspended in the water column, right? So we use a net like that. And there are some, actually many, that are in the mud, that live in the mud. So we need to sample the mud and then screen that mud and then look what is left on the screen. Okay, so this is one community, this is another community. There are some species that repeat, but very little. You are really talking about 2 different communities of macroinvertebrates, aquatic macroinvertebrates. Okay? So we did that in order to look a little bit at the function, not just the structure, a little bit at the function. We tried to assign functional feeding groups. These are the categories we use, and this is based on what those animals do in a pond, right? So there are shredders, there are scrapers, there are filterers, gatherers, and then even predatory insects, basically insects, aquatic insects. Okay, so we look at that. And we also sample water, so I want to use this to show you what kind of things can be measured, or what kind of parameters are important for life and for assessing the health of a wetland, right? So those are water parameters, easy to measure: temperature, specific conductivity, which means has to do with salinity, is a derivation of salinity. Dissolved oxygen, very important, but changes a lot over the same day. And also in the surface is more oxygen, closer to the bottom less oxygen, so you need to standardize that. pH, turbidity, how clear the water is, that tells you some things. Chlorophyll A, important, because chlorophyll A is an indirect measure of the size of the phytoplankton community. Phytoplankton, the little microalgae floating and suspended, they are green, they have chlorophyll. The more chlorophyll concentration in the water means the more phytoplankton it is. Total phosphorus, nitrate, ammonia, so those are nutrients, all these are nitrogen, and this is a measure of phosphorus alone. Okay, so those are important things to measure in a wetland, and they have an ecological significance. We are not just measuring this just for fun or randomly, but we do because when we see what happened with the community, who's there, who's not there, what kind of organisms are dominating, these kind of things, this data can help to explain. Okay. We also look at the sediments. It's another thing that you can look in wetlands. It's a little bit more messy, right? You need to process the mud. So the two things that we did, and many people do relatively standard, is looking at particle size using different screens. So we determine the proportion of fines, like clay and silt, then sand, and then gravel, and things like that. So that gives you an idea of the habitat for the benthic community. So benthic community, in some species may be more at ease in very fine sediment, muddy sediment, others in very sandy sediment, these kind of things. We also look at the organic matter content of the sediment. And this is some of the results. So you just look at the three resacas, new, intermediate, old. They all have relatively the same kind of substrate. Right? So there was not really big difference. They are dominated by fine particles. We're talking about the surface layer of the mud. So that was good news for us because we want to assess the effect of time, succession, colonization, right, from day zero. So we don't want that some difference, big difference in the composition of sediment, for example, can affect the development and can be a confounding factor. And this is organic matter, total organic matter in the sediment. It varies from 7 to 11, something like that. This is not a significant variation, and is, just for reference, is a little bit more organic than the regular soil in the lawn here. Okay, regular soil in the lawn here will have like 2%. That's normal. All the way to 5% in very good soils, very rich soils, but no more than that. So there is a little bit more organic matter in the sediments than in the soil around. Any idea why? Why there is more organic matter in sediments than in soil?
She said decomposition.
Yes, why?
Because the water decomposed it and the whatever micro stuff was in there.
No,
that
there
you
is
were
more.
explaining.
But there is more, not less. There is more in the water. This sediment is covered with water, right?
Yes.
It's in the bottom. And there is more than in the soil. It has to do with the composition. The composition is faster when there is oxygen, presence of oxygen. At the bottom of the, at the bottom of the resaca, there is not as much oxygen as in the ground here. So the composition is lower. Organic matter tends to accumulate. So that's a normal result. This is just to show you again the kind of numbers that we get measuring these important water parameters. Seki depth is a measure of the clarity of the water, turbidity by opposition. And it's in centimeters, you know, it's a Secchi disc, it's a disc like that, has two colors. Very simple, very standard. Everybody in the world uses the same thing, so it's been very standard. You just, it has a weight going down, and as soon as you cannot see it anymore, then you measure that distance. 21, 41, 26, 24. So we have this, so that means resaca water is relatively murky. You know, 20 centimeters is what you can see. Intermediate resaca, however, is a little bit clearer. There was a lot of macrophytes, a lot of aquatic plants. You may have seen that in several farming if you have visited that. So that was expected in that sense. pH, very similar. Conductivity, very similar. So conductivity is a measure of salinity in many ways. These values of conductivity are still fresh, but not very, very fresh water. It's not brackish, but close. Okay, still fresh, but not that fresh. Not like the water tap in the tap. Dissolved oxygen, when it's higher than 2 milligrams per liter or part per million, dissolved oxygen, when it's higher than 2, is conducive for life, aerobic life in the water. So it's something that you can remember. Look at the values, it's fine, no problem with oxygen, at least in total resaca. Temperature very similar, so we don't have very big difference other than that, but it's not critical for aquatic life, and macroinvertebrate aquatic life. So that's good news because we don't want difference in these parameters, we just want that difference is time, and see what time makes in terms of changing the community. That's another interesting, those parameters based on, this is the chlorophyll concentration. So we measure chlorophyll concentration in the water, which is an indication of how much phytoplankton is in the water. Because chlorophyll is in the phytoplankton. And there is this trophic state index proposed by Carlson. You may have heard of it. Carlson's trophic state index, proposed in the 70s, is still very much in use. It's a very clever index, and based on, it's a little formula based on this concentration, and there is a classification. So depending on the value you get in this index, you can classify the trophic state of the water, the water body. So as you can see, they are all in the category of eutrophic. So resacas are naturally eutrophic. They may go hyper-eutrophic, a little bit higher. They may go a little bit less, in some cases, mesotrophic, but never oligotrophic, which is clear water like in a river creek, in a mountain creek, right? So they are eutrophic. Again, good news, no difference. Very similar. That's good news for us. And those are characteristics. I mean, this is a principal component analysis to show you which of these parameters are the more driving the difference, and we see that there are no much difference. So sites are comparable in terms of physical-chemical parameters of the water. Good news for us, because we don't want to test those differences, we want to test the difference with time. So these are just, I'm showing you just the Baltic community, not the water column community. So just look at this data. New intermediate, all, there is always highest numbers, for example, in total number of taxa, total number of species, or if we do not identify to the species level, it will be to the family level, things like that. But it's a little bit higher. So this is a measure of diversity, right? Family richness, a little bit higher than the old, for example. And total abundance, a little bit more abundant, okay? This is an MDS plot just to show you the three resacas, the community, the Bentic community, right, is a little bit different. So in this case, the community is different. The animals living in there is different. Not the water parameters, but the animals. You see the grouping, right? The green is over here, the red is more here, the blue is over here, but there is an overlap, blue-green, blue-red over here. So new and intermediates have some commonality, but these two are really apart from the old. So the community in the old resaca is showing different, right? So again, physical-chemical parameters are similar, but the communities are not. So time is what is making this difference, and that's what we wanted to check. So that was confirmed somehow. So now we want to look at who is there, who's not there, and understand the succession. Which species arrive first, which species arrive never, this kind of thing. And just to give you an idea, so we have this kind of conclusions. This is the species, not all species, those are actually families, right? It's hard to identify all the way to species, but how they arrive over the years. So this is the new resaca. So 19 families, 11 were already there during the first 3 months, and 4 more after 6 months. So it was quick colonization, really fast. This is comparing the 3 resacas, these families here, the 3 resacas, and also we sampled the river Grande, which is, several families next to the river, so we have access to the river as well. So we have difference. We see, for example, this family here is only present in the intermediate resaca and not in the other resaca. So there are really different. And so the colonizers in the new resaca are a mix of active and passive. So active may have flown into or arrived with birds and things like that. Passive arrived with water. This water was pumped, this kind of thing. So in order to show you an idea, well, this gives you an idea of an index. Actually, there are 3 indices here that were calculated with the number of different species and the abundance of each of these species. So this is a measure of diversity. It's better than just the number of different species. It's that plus how many of each of those species, and those indices take into account that. So this is an evenness determination. So look again, intermediate resaca, higher diversity index with this index and with Shannon as well, but not with this one. This is the most reliable. This is the one we like best, and it's showing a little bit higher diversity. But the most important difference in the community may be here. This is a dominance plot, which means how many species are or were found, right? This is a semi-logarithmic scale. How many species were found and how much each species dominates. So the important thing of this graph happens right here. One species in the old resaca, right? One species, old resaca, composes 60% of the community. So the old resaca have a macrobentic community dominated, 60% dominated by one species, compared to the other resacas, the new and intermediate, that one species dominates 25, and another at the second species another 20 or 25 here, etc. So it's a big difference from here to here. And you know what that species is? You've seen that? The little snail? Well, this is Esmelanoides tuberculata. It's a cone snail, this big. All resacas are completely covered with those. And the benthos, I mean the moth, there's no more moth. There's a layer this thick of shells, dead shells. So it's an invasive species, introduced probably with the aquarium trade. It used to be an aquarium species, and it is in every single resaca around here. And you will find them, perhaps not the first year, because we didn't find them in the new resaca, but as time passes, it will come, it will overtake the benthic community. And it's not just that. I mean, it's a snail, so it's a scraper. But the problem perhaps is the shells. They die, the shells will not decompose. The little snail will decompose, but the shells will. They remain a long time. So after a while, instead of having a mud, which is classed as the natural state of the resaca's bottom, a mud where the benthic community likes to live, these little critters like to live in the mud. Well, there is no mud anymore. It's like gravel made of shells. So they are really changing the benthic environment. Yes.
So in the resaca restoration, are they trying to get rid of those shells?
What the city is doing, I mean, it was not planned, but it's happening because they are dredging.
Right,
So
right.
all this is removed, and with a layer of sediment that is maybe very thick.
Right.
So yes, but it's a matter of time and they will be back. And a layer of shell will happen after a few years.
Is there any way to get rid of it?
Not that I'm aware now.
No one's doing a study.
Yeah.
That's
How to get rid? I mean, you can perhaps control somehow with some biocontrol methods the species, but the shells will remain many years. If they are there, you will have to dredge.
You kill the species, but the shell remains.
Yeah, it can be there. Okay. Another thing. Feeding groups, the functional metric based on community, which is not 100% functional, it's more structural, but it gives a hint of the functioning. So look at the difference, right? In the old resaca, scrapers dominate in terms of feeding groups. What scrapers? The little snakes. Okay, and in the other resacas there are other dominants, so there are gatherers that dominate the community, right? So the functional, and the other thing is, in the new resaca, you may see a more balanced distribution compared to the others, right? You have a little bit more of green compared here and here, right? Perhaps not enough scrapers, but scrapers will arrive with these melanoides. So that's another indicator. Is showing clear difference among resacas, and those differences have to do with time. So trophic structure is changing. It changes over time. Let me go ahead and try to go faster. So yeah, some take-home messages. So colonization occurred rapidly. During the first year, the community established different proportions, but there was a diverse community. Okay, this is so another indicator. In addition to the feeding groups, in addition to the diversity indices, is the presence of an invasive. That can be an indicator, and that was the case in the resacas. Again, the snail is another indicator that can be used. And in the paper we published, we said that, okay, in addition, and one important thing, in addition to the other indicators like the feeding groups and the diversity indices, the presence of an invasive was detected in the benthic method, because this paper was a paper we wrote comparing the two methods, the net, the kick net, and the benthos, the coring. And we concluded that the benthos is better for several reasons. There's more consistent data, and the coefficient of variation is less, etc. But in addition, we could sample these, and we could measure the abundance of this. With the net, they are not there; they are in the bottom. So we miss you miss those in the net with the net, but not with the benthos. Okay. So among other things, resacas are virtually unknown biologically. So it was the first time that the benthic community was assessed in resacas. So that's a reference there. And over time, diversity and redundancy decrease. So the community simplifies. That's part of the succession process. And diversity, trophic structure are good metrics for discriminating between sites. So these are potentially good indicators of recovery. in a reconstructed resaca. And so that's for that one study case. This is another study case. Until what time we have?
Till 9.
Till 9? Okay. So I'll go faster. So this is another study case about resacas again, and it happened after. So this was done by, not done, but it was taken care by Buford and all of my students that came after Leah. And what we wanted to do with his project is to actually measure many things and construct a super index of resaca health. So something that will help us say, okay, this resaca is healthy, this resaca is not healthy. And so it's more than just the bentos, okay? So ecosystem health, again, I told you, function and structure. You can add a third aspect to the health of an ecosystem, which is resilience. So good structure, good function means a healthy ecosystem, or is a way to measure that. But if in addition that ecosystem is resilient, you know what is ecological resilience, right? What is ecological resilience?
And if it's damaged, it can come back for it.
It come back, it bounce back, right? So if it has resilience, it's good health. It's an indicator of good health. So we were measuring with Buford function in several ways. Well, you can measure function in many ways in an aquatic system, but we were focusing on decomposition. It's a process. Primary productivity is a process. I'll show you how. And in terms of structure, there are several communities, you know, plankton, benthos, fish, vegetation, microinvertebrates, and we focus on vegetation, riparian vegetation, somehow, not directly, and the fish community, not the benthos. Buford didn't like to work with mud, so, and he really says he's a fisherman. He's a fisherman, so he says no fish. Okay. So yeah, he was so happy fishing, getting that fish. So invertebrate, we marked this because we tried at the beginning because of Leah, what she accomplished. So we said, okay, we need to test that, but it drops. So we focus with fish in the case of Buford. So resacas, this is the resaca systems around Brownsville. So there are several resaca systems. Resaca del Rancho Viejo, Resaca de La Palma, Fort Brown Resaca, which is this little system here, Cemetery Resaca or Downtown Resaca, this another system. So there are 5 ones. And each resaca has its ponds, right? They are not necessarily all continuously flooded. Anyway, so we decided to sample to pick one resaca from each of 4 systems, and then assess health or develop this health index, and then compare. Okay, so all this is just story about resaca. Let me go faster on this. So we know that the only permanent habitat, freshwater habitat other than the Rio and the Arroyo Colorado, talking about permanent resacas, not ephemeral ponds, right? Rely on pumped water, rainfall, stormwater runoff. So these are novel ecosystems that are controlled, but very critical for many things. And they are in different health status. Some resacas are very degraded, very impacted by urbanization. Some are in much better health, biologically and ecologically. So we did, we worked on 6 resaca ponds, and I will show you the ponds. Let me go to the ponds, right? So this is Fort Brown and Lozano Banco. This is by the university campus. You see them there. We have this, which is Cemetery Resaca. This is by St. Joseph Academy. And this is, what's the name of this? Anyway, and these 2. So this is the VICC, Resaca de la Palma, as a pool of the Resaca de la Palma VICC, you know, the golf course here. Okay, so those are the ponds that we tested, and this is Billy Mitchell. Billy Mitchell is the best Resaca in good health for many aspects. So we measure the parameters that I told you, similar, okay? We also measure, look at the sediment, also look for the particle size distribution. We already talked about that. And we measure the composition using a technique that is called the litter bag technique, which are mesh bags. We put some substrate there, which in this case was sable palm fronds, or pieces, little chunks of sable palm fronds. Put it in there, put it in the water, and retrieve them 60 days later and see how much mass has been lost, and then we calculate decomposition rate. And we look at other things, and we have to do some corrections, but I've been using that since I was in Mexico as a reliable functional indicator, because it indicates the rate of one process, what process, decomposition. Okay? And so we also sample fish community using experimental gill net. That means it had several panels with several mesh sizes, so we had different fish sizes that we capture. We capture, ID, measure, and return. So the only ones that we didn't return were the exotics, for like the armor catfish that is everywhere and is exotic, because Texas parks ask us to not return those fish to discard them because they are invasive. So it's like helping a little bit in that sense. Okay, so there were several species like that that were not returned. This is beautiful, by the way. This is David Lecce. He's now starting a master with me, starting this semester in another. Actually, it's a continuation of this project. We need to validate this index published. So he's taking over. And we look at the riparian habitat, you know, the shores. And we need to assess different things. We follow a method that was developed in Spain to assess the health of the riparian habitat based on many things. And several aspects, I'll show you which ones. And for that, we use a drone. So Buford was very, very happy flying that drone and taking pictures. And those pictures were analyzed then with software in order to estimate how much of this, how much of that, the proportions and things like that. So that was done. That was done for the riparian part. And we also look at the trophic state index based on chlorophyll. This is a decay constant that has to do with the decomposition rate, right? We also calculated some metrics from the fish community that we sampled, and we actually kept only Shannon, dominance, and numerous piscivorous species to richness in order to compose the index. So I want to get to the index. So this is the kind of metrics for the riparian based on the drone. So we have, it's a semi-quantitative system. We assign points depending on the cover of vegetation, and if the vegetation is woody or is just grass, and we have some adjustments and this kind of thing. If there is an alteration, for example, if there are walls or not, or if there is a restriction, like a little grips, the restriction of the channel, these kind of things. So those are taken into account to estimate or to determine the quality of the, this is the safety disk for measuring turbidity. But I want to show, okay, this is the index. And let me show you, yes. Resaca Health Index, and it's made of 4 components, so it's a multi-metric index because it's made of several metrics. So this is the riparian index based on the drone determinations and the values. fish community index based on the fish community diversity index, richness, piscivorous species. K is a constant derived from the decomposition rate. So we have a functional component here. Trophic state index, which is based on the chlorophyll, is also a functional component because it has to do with primary productivity. Structural component and habitat component, the habitat in the riparian zone. And it worked very nice. We had to tackle the way to determine a reference condition. When you evaluate the ecosystem, you always have to determine established reference conditions. So you are evaluating whatever is going on here, but to compare to what? How can you say this is healthy or not? Like when you go to the doctor will take your pulse, will look at your blood test and things like that, and how can he say that you are high here or low here? Because there have been like a lot of humans that have been analyzed, and we know what is a healthy human, and that's the kind of thing. But for resacas in the town, there is no such a thing as a reference resaca because they are all manipulated. So we need to decide how to establish a reference conditions. And what we end up doing is we determine a virtual reference resaca. So each component of the index, we look at the best condition in the 6 resaca, which was the best for decomposition, this one. So this is a reference here. Which was the best for the fish community, this one here. So that's our reference here. So we compose an imaginary reference resaca based on the best metrics of all resacas, and we compare all against that. And it worked. It was very interesting. But so this is just to show you. For the fish community index, is made of 4 metrics, and this is one metric of the resaca health index. This is just an example of the results we got. We have 6 resacas here with the different components of the index, and this is the evaluation index. Okay, so the best resaca overall was Lozano Blanco.
Where is that one?
It's by campus. It's
by the campus?
In campus. Yeah, it's where there's a bridge, a walking bridge. That's the best one. Based on that, the second one was Billy Mitchell, which was very good in many aspects, but perhaps not the best. In the fish community was very good, but BICC have interesting fish there. I know I used to live by there, and we used to fish there. It's a lot of things. So BICC, the resaca in front of BICC is very interesting. So it's in good condition for some aspects, but not very good for other. The riparian habitat is not good. You know, there is the golf court and the golf field, and it's not natural riparian habitat. So it has low rating here, but high rating with the fish. This is the overall rate, etc. Okay, so I don't think there is time to go over the next case study, which is the Garrapato assessment. It can be. Do you have any questions?
What did you do with your data? Did the city get it? Did the state get it? Or what happened? I mean, is there anything that somebody has to do to improve, let's say, which is the lowest one there, Fort Brown?
Oh, yes. Well, as I said, we need to validate this index. So validate means, and this is my new student will do that, try to do that. Validate means testing this in much more resacas. Because we developed it in 6, but we need to test it like in 20 ponds, not resacas, but at least some resaca sections of ponds. And keep polishing, perhaps removing parts of these or parts of the other. So try to make it simpler, validating and say, okay, this is consistent, and then we can recommend that to PUB or whatever agencies managing resacas in that case. This is too early to tell them, okay, use this. So we need validation, yes.
What agencies are managing resacas?
It's PUB in the city and the irrigation district outside the city, is my understanding. They pump water from the river, so they have pumping stations and they fill. And the only thing they manage really is the level of the water. UV is going I mean, with the restoration project, dredging. They call it restoration project, it's basically just dredging. But it's the first step, right? And they are now planting, they are planting the shores in some places, yes.
Can you also swim? Is it safe to swim, or is it safe to eat the fish from the resaca?
Yeah, I will,
Catfish, no.
the fish, I will not eat the fish, I don't think it's a good idea. But swim, I don't think it's, I mean, Billy Mitchell looks good in a hot day. You may need to shower at the end of the day. But I mean, you will not get sick, I don't think you will get sick. Fish, I will not eat the fish. But I know people eat the fish.
Yeah.
And they're still alive.
And the restoration, what are they doing with all the shells they're bringing up from the snail?
It goes with the mud. The shell layer is this thick,
Uh-huh.
and they are removing like several feet of mud. So they are dredging this, pumping out, and they are draining that. They are, how do you call it? But there are plans to drain that, so a little bit to dry that, and then they send it to the landfill.
Oh.
So landfill is used like a cover, you know. After compacting, every day they need to cover whatever they.
So that's what they're using.
That's what they are using.
So
Yeah, it's a good project, honestly.
And what effect did on the old resaca have with those snails because of the farmland and the pesticides and fertilization that they used? Did that impact it, the old resaca?
That's something we didn't test directly.
Oh.
Because we didn't check concentrations of pesticides or other contaminants other than nitrogen. Nitrogen was not bad, if I recall well. But yeah, I don't know about the other contaminants. But it didn't look that bad from what I remember, the other data.
Because in the old one, the 60% of the life was those snails, right?
The community, yes, 60% of the community, it was those snails alive, in addition to the layer, right?
So the pesticides didn't do them so much good.
Yeah, this resaca is used a lot, so sometimes we went there and it was full, and sometimes it was like 2 feet down, still with water. So the water replaces a lot. It's not that stagnant. Because they use it and then they pump new water and it goes like that and like that. So that I think is one way that resaca keeps good quality, the water.
Oh.
Yeah.
Is there any other species besides the armored catfish that the state asked you to keep out or toss?
Yes, it was the carp, which is not from here. There's a large carp. There was one picture. It's a long way. A carp and the channel catfish is being introduced several times. It's
Is that the spotted one? Kind of.
I know the armor catfish. Yeah, it looks like. Yeah, it's brown with black spots sometimes. It's very beautiful fish, spectacular fish. It has a very, very hard head, not much flesh. It's everywhere, and it comes from the aquarium trade. You know, you can still find them in PetSmart this big, but in the resacas are about this big, bigger one. No, maybe this.
My question is, there's one catfish that we get sometimes that's patterned. It's gray with white, beautiful.
Yes, it's the blue channel catfish.
Okay.
This
Now,
is the channel catfish. This is not invasive. It's not really reproducing. Not sure it's native, but you know the city introduced them every year for example, in the convention center every year they release those. So they still there some, but they are not dominating or invading. I don't think it's native, but it's not an issue. So the carp is there. The tilapia is all over. The tilapia is also invasive, yeah, that's another one we have to throw. The tilapia, the armored catfish, the carp, the shad.
sometimes the shad, you know, they are like this and white. Sometimes they are like this. Shad, you know the shad? They are planktivorous fish. You will not catch them with a rod, just with the net. So those become quickly dominant if there is eutrophic conditions because they are also phytoplanktonic. So they filter with their gills, so they eat phytoplankton and zooplankton. Yeah. Okay. So anyway, you know where to find me if you want to keep talking about some of these things. You have my email. If not, if you look for me in the UTRGV webpage, you will find my address as well. So we're there if you want to talk about it.